Go to design sources and right click and then add sources. Click the add or create design sources, then do next and then create file. So we are going to create a VHDL code. So select VHDL and the file name should be we are creating half header and half separator. So file name will be ha underscore hs. So this is my file name. You can keep it according to you. So keep one thing in mind that file name should not start with any number and there should be no space between the characters. So after putting the file name, put it as HA and HS already exist in my system. So I will change the name to HA and half subtractor. Okay. After creating this file, finish. Now here we have to change this behavioral model to data flow model. Then we have to write the ports. As in half header there are two input ports, and also in half subtractor there are two input ports A and B, right? Then for half header there will be two outputs. One will be sum and the other will be carry, that is C. So sum will be output and C out will also will be an output. Now coming to the half subtractor will be the output of half, half subtractor will be difference and borrow, right? So these both will also will be an output port. After setting the ports, click on OK. So the file will be created. Here we can see that a half subtractor and half header and half subtractor file is. Double click this file and now go to simulation sources and open that sim1 and put this half subtractor and half header file as top, right? Here we can see that half header and half subtractor file is at top. Here also put the half subtractor and half header file as top. Okay, now coming to the code. Here is the code. We can see that A, B, sum and C out, all the ports are written here. So after begin you have to write this you have to start writing the code. Remove these commented lines which makes our screen spacious. Remove all these commented lines. Now coming to the code. After begin we have to write the code. So what will be the sum? Sum is the sum will be A XOR and C out will be A and B, right? And what will be the difference? Difference will be again A XOR B and the borrow will be not not A, not A and B. Okay, so our code is ready. After writing the code you have to save. After saving you have to go to RTL analysis, open elaborated design, then go to schematics. After clicking the schematic, this dialog box will appear, so click OK. Our schematic, so wait for loading. Okay, now we can see the schematic on the window. Wait for a few minutes. Here we can see that this is our schematic. So this is our this is our AND gate with a NOT gate, that is for our half subtractor. That here we can see that it is giving a borrow, and this is giving a sum and difference both XOR gate, and this one is giving the out, that is carry out. So take the screenshot of this and then after this go to simulation and then run simulation and run behavioral simulation. Okay, you will get the simulation window. So coming to the simulation. So here we can see the simulation window, and also we can see that all the input ports and output ports are present here. So coming to the input ports, like A is our input port, so go to force clock, right click it and go to force clock, then go to then select binary, and then our leading edge will be 1, trailing edge will leading edge will be 0, trailing edge will be 1, and we are taking period of 200 nanosecond. Okay, now coming to B, so right click on B and then go to force clock. Same here also hex binary, and then 0 and then 1, and then our the period will be half of that previous input, that was 200, so now we have to take 100 nanosecond. Now click OK, and then after the oh sorry, first you have to click on restart. Okay, click on restart, then set the values, go to force clock, set the values, like binary, then 0, then 1, then 200 nanosecond, right? And then go to B, and then force clock, and then select binary, and then 0, then 1, and then 100 nanosecond. Okay, here also we have to write 200 nanosecond, because we are running for 200 nanosecond. Okay, 200 nanosecond, and after setting A and B, click this button, run for 200 nanosecond. Okay, click this button, so we can see that waveform is visible here. So how to see the waveform? Wait a minute. So to see the waveform, click on this zoom fit button. Zoom fit, you will click. So here the waveform is visible. Waveform is visible, and you can take the screenshot of this waveform. Thank you.